All right. So today in class, there was some confusion about the toggle code that we wrote today. So I wanted to go over some things so you could watch this at your leisure and go over the basic elements of our programming language here. So right now I'm in the Arduino IDE. I will include a link when I upload this to the web editor if you want to, play with this at home. And I'll also include, the sample code in the classroom as always. So you'll see the toggle code and our button code, which we wrote on the first day. So when I load up Arduino, you should see something like this. Right now, my sketch isn't saved. Again, you just go to File, Save As, and you're able to save your .eno file. Those can be, shared and opened as you wish. When we launch up our program, we have two areas here. We have our void setup and our void loop. As we talked about in class, our void setup here, this runs once, right? So it runs top down, just like a book. When it hits the void loop, it's going to run this repeatedly. And this is where the main portion of our code is going to go, hence main, right? We're coding in C++. When you go and you look at other programming or when you look at other programs written in C, they typically have what we call a main component, and that's where a majority of the code will revolve. So here I'm hitting enter, and I'm going to put my variables up here before my setup. So today we're going to write a basic program just to toggle our LED. So the first thing that I like to do is to write the variables that we need for our pins, for our actual mechanisms. So today I know I'm going to need a button and I'm going to need an LED. Both of those can be saved as integers, so we're going to start off with a declaration of int. Remember, an int is any whole number. So the first int we're going to use is our button pin. So the proper formatting for a variable is always lowercase and then uppercase. So we can set this button pin is equal to 2, I believe is what we used in class. So that's going to go into our digital 2 port. With the // command, I can add comments to make notation for myself or for my peers when I go to share this. So this is going to be my button plugged into D2, which is digital 2. We'll talk later about the difference between digital and analog because there is a very, very important difference between the two, making them incredibly useful in different situations. So our second one that we're going to have is our LED pin, so integer LED pin. And we're going to set that equal to 3 because that LED is plugged, can't spell today, plugged into D3. Fantastic. Now, with that said, this is an optional variable, but I think it makes the readability of our code better. We can do a button state or button press, something to that effect, something that'll hold the state of our button. If you remember, we talked binary, right? A button can either output a 0 or a 1. So I'm going to create the button state variable, and I can just set that equal to 0. We end every line with a semicolon except for our if statements. So that's something to watch out for. I'll make sure to remind you of that later when we go into our void loop. So this is simply going to hold if a button is pressed or not, right? A 0 equals not pressed. 1 equals press. Perfect. Now the last thing that we're going to use is a kind of a unique variable. You can name this whatever you want. I'm going to call it toggle. So toggle is going to be equal to 0. This code is going to flip-flop this variable from a 1 to a 0 depending on what it is that we want to do. So this will flip 0 to 1 depending on last action. I guess the best way to describe it would be that it's flipping 1 to 1 depending on LED state. So whether or not the LED is on or off. So that should really be all that we need to get started. Now we need a couple more things. So in our void setup, right, again, this is only going to run one time. This is where we put some core setup files that we're not too concerned about repeating every single time, or that we don't want to repeat every time. I put my curly brackets here because it's nice to see a top and a bottom, so I know exactly where that goes. I'll do the same thing here. We can delete this default text since we already know what we're doing, and this isn't very useful to me. Perfect. So in my void setup here, I'm going to put the same thing that we always put. I like to indent to keep it neat. A serial dot begin 9600. Perfect. So that sets the refresh rate for our board. If you recall, on one of the first days, we played with the printouts when we first got our hands on the boards. We went up here to our serial monitor. When I click that, right now I don't have an Arduino board connected, so it's going to give me an error, but that's going to allow me to print out information to it, which will be a huge help. The last thing that we have to do is we have to set our pin mode for our LED. So to do that, we type pin mode, and we want to specify a pin and whether it's an input or an output. So in this case, I'm going to do my LED pin first, and we're setting that to an output, meaning I need power to go there to turn on my LED. The other thing we're going to do is set our pin mode for our button pin to be an input, because we're expecting the user or somebody to press that to make something happen. I know this seems like a lot of work to get an LED to run, but it's really incredible that things around us that are programs, right, are written in this way. And this is awfully, a lot easier than writing a lot of ones and zeros and writing machine language, because we're using the higher language here. So right now we have our base set up. Everything's good here. We specified our outputs for our LED. Just say output for LED and a input for our button. Again, this is all just notation to kind of keep our head straight so we know exactly what's going on, so it becomes less confusing. Great. Once in a while, it's a good idea to come up here and go to auto format to make sure that your code is formatted properly, and that everything is nice and neat and that your curly brackets line up. So right now we're ready for our void loop. So this is where all of our actual code is going to occur. So the first thing we should do repeatedly, again, this is looping, we want to make sure that our button is being read. So we're going to take our value button state, right? So this is what's holding. This is a box that's going to hold a 1 or a 0, depending on if the button's being pressed. So our button state is going to be equal to a digital read of our button pin. One issue I saw a lot was instead of button state, people would write pin here. That's incorrect, right? Because that would change the value of our button pin, which would then result in us reading some random area, which might not be what we want. So if we're changing the value of button state here from a 1 to a 0, then we're getting the readout from the button. All right, fantastic. Now we have the actual logic that's going to be happening. So we're going to write an if statement. So if my button state is equal to 1, meaning that somebody is pressing the button, we want something to happen. Kind of a nifty little trick here. When I make my curly bracket and I hit enter, it's going to make another one for me. This is a nice way to keep our head straight and make sure that we aren't missing anything. So again, you have the top button and the bottom button there. So I know that I'm going to have an if button state equals 1. After this, I could put an else, right? In case, I'm not pressing the button. In this case, we don't want to do anything if somebody isn't pressing the button. We only want our code to act if somebody is pressing the button. So we're just concerned with this for now. Inside of here, right, we can put what we call a nested if statement, which is an if statement within an if. So we are asking the question, is my LED on? And then should it be off? And vice versa. So when I press the button, we're going to ask the question, if toggle is equal to 0, meaning that's my first go of it, which means the LED is probably off, are we going to turn on the LED? I say so. So we're going to digital write our LED pin to high, meaning that our LED is on. Okay. So again, this is button pressed. This is what is the button state? Pressed or not? Perfect. So if toggle, again, this is our flip value for LED on / off. I'm going to put or, since it's bad practice to put slashes within your comments. Cool. So if toggle equals 0, right, then we're going to turn our LED on. And I say it's a good idea for us to set toggle equal to 1 now. So that way the next time we come back, right, it's going to do the opposite. So underneath it, we could either put an else, or we could put a if toggle equals 1. But that actually would cause an issue. So we're not going to do that. We can talk about this later in class. I don't want to confuse you, but if we change toggle equal to 1, it's just going to immediately kick into here, and that's going to cause an issue. So the best course of action is an else statement. So else simply says, hey, if toggle does not equal 0, right? If it equals something else, then you're going to do this instead. So it's a this or that. All right, perfect. So you can see how this is getting organized now. We have our top here, which lines up to the bottom. We have our first if statement, which lines up to here, our nested if, and then our nested else. Perfect. So if toggle doesn't equal 0, it's probably going to equal 1. So we're going to change the value of that and write our LED to low, meaning it's off. So that's our flip-flop there. So I can write digital right. Our LED pin is going to be low in this case, meaning that we're turning it off. Trying to be consistent. You should have LED all caps, but these are just comments. It's all right. Under here, we're going to set our toggle back equal to 0, meaning the next time that we come into the sub, again, that's the term that I use for these curly brackets, everything that occurs with it. This is a sub here. So I'll be able to set toggle equal to 0, and then come back in and turn it on, and then off. So this should be alternating, okay? So I'm going to write right here, next time the button is pressed, go to turn LED off. Cool. And here it's the same thing. Next time the button is pressed, go to turn LED on. Perfect. Now, the very last part that we're missing in this code is our delay, right? So this was a lot so far. I'll post this code up for you to say, is our delay here? I like to put a delay of 250 milliseconds. Okay, that's about a quarter of a second. So this quarter second delay is to allow time for the person to release their finger. If this code wasn't here, if we didn't have this, it would go so fast that you might not even notice that the LED turned on and off. It might actually go through the sub 300 times by the time that you can lift your finger. So this makes it a little bit easier for the person to see. We'll do a demo tomorrow in class so you can see a little bit more about that. Okay, so that's our quarter second delay for human reaction time. Perfect. All right, so as is, this code would be good to go. I always auto format before I go and upload it. And there's two buttons up here, right? So we have our upload button, which would send it to the board. Again, I don't have my board right now, but I can verify it. If I click verify, it's going to give me a heads up on how I'm doing. So here were just a couple test demos I was doing. So I can just call this toggle code tutorial. Perfect. And then you can call it whatever you would like. When you save these within the Arduino file, it's going to create a new folder for each one that you go ahead and you do. This is poor naming. I don't know why I call it RRR. Don't save anything within libraries. This here is going to be referenced later. We'll talk about what we have to do with our libraries. So I can go ahead and save this, and it should compile it for me. Again, remember, we learned about compilers. This is going to go through my code to make sure I don't have any syntax errors. If there are errors, then it would present them down here. Hypothetically, let's see what might happen if I did have some errors, okay? Let's say I forgot this semicolon. I screwed up. I go ahead and I go to verify it, and it's going to give me an error. So let's break down what it's saying. Exit status. It's expecting a semicolon before this. Well, that's a lot. And then above it, it gives me a little bit of information that might be confusing to you. So it's simply looking for a semicolon before this. So that tells me that right before this, there should be a semicolon. Very good. So I can add that, and it would compile normally. Now let's say I forgot a curly bracket. I forgot maybe this one and this one. I really messed up. So when I go to verify it, it's going to hopefully kick out a couple errors. But this time it didn't, okay, because it didn't line up. So that could be cause for concern because it still finishes out all right. And the else statement here is being skipped over. So if I did have this here and I was missing my closing one, again, when I mouse over these, they link up, right? This one here doesn't have any connection at the bottom. So if I go to verify that, it's going to pull an error, and it's going to say that it expected a blank at the end of input. It expected this curly bracket or the bottom bun of our sandwich. So here I can put one in. You'll see that it matches up, and I'll verify, and I'm good to go. Remember, the key to programming is applying yourself and just not giving up and working hard every time. This isn't going to come easy, and this might honestly be the hardest code that you write all year because it's your first. As we go, things will get easier, and you'll get to experiment with a lot of new sensors and tools. I hope that this helped. If you have any questions, please reach out to me or talk to me in class. Thanks. Talk to you later.